In the development of foldable structures based on 4D printing of biopolymeric materials, with the help of 3D printing that allow us the creation of complex structures, opening the possibility of developing devices for ergonomic support and rehabilitation of human organs and limbs. The main goal was to develop a structure with materials that were able to react to external stimuli and modify its shape and then have the capability to turn back to its original shape. In order to achieve that, we proposed two biopolymeric materials, polylactic acid and polycaprolactone, which offers a promising alternative to develop biomedical devices in order to replace the metal wire ones that often tends to generate muscular inflammation and scar tissue depends on the zone that it was implanted. We use SolidWorks as a software that help us to design the scaffolds. We also use Creality CR10 V2 printer, and we took the percentage of total deformation in account in order to analyze the behavior of the material. We also propose a biopolymeric material base on the mixture of both polylactic acid and polycaprolactone. We showed those results in the graphic below. Although the PCL seems like a promising alternative, it is pretty unstable in order to maintain its shape or recovering it with success. Polylactic acid, on the other hand, works just fine, recovery pretty much 100% of its original configuration, with the exception that it might have a few cracks on the crystalline walls. Well, we showed a few cracks on the crystalline walls. The mixture of both materials showed a great recovery capacity, but it also seems to work pretty high under pretty high temperatures. We also tried chemical superficial modification in order to achieve better cell adhesion and proliferation. Each material went under three different treatments. One was covered with gelatin, the other was covered with polydilysene, and the third one was just the material as it comes out of the printer, with just a regular sterilization process, which includes ultrasonic cleaning and a UV light to dry them off. We also include the pictures that were obtained using a confocal microscopy. In the first row, we can appreciate the polylactic acid results under the different treatments. The first one is the polydilysene results, the middle one is the gelatin modification, and the third one is the material as is. The second row it shows polycaprolactone 4D printed scaffolds as it was influenced by the surface chemistry modification. The first one's been the polysine modified one. The second one is the gelatin, and the third one is the material as is. And the third row it shows the mixed materials, which would also show a pretty good cell addition and proliferation. If we compare the three first pictures that they are the scaffolds that were treated with the polydilysene, we can deduce that there was indeed it provide a better cell addition and proliferation.